Hi all, in this video I'll be discussing the objective questions from guided tutorial subtopic 5.1 Hydrocarbons, Alkanes. Let's look at the first question. The following compounds are alkanes except, here you have to remember that alkanes can be your straight chain alkanes as well as cyclic alkanes. Alright, so for straight chain alkanes, the general formula would be CnH2n plus 2, and as for cyclic alkanes, the general formula would be CnH2n only. So all you have to do here is to match the molecular formulas given to you to this general formula. So as we can see, the first one does match the general formula for straight chain alkanes, and the fourth one as well. Okay, and the option B, C6H12, matches with the general formula for cyclic alkanes. So this here is a cyclic alkane. Alright, and C would be our answer because that does not match with the general formulas of our alkanes. Next, choose the true statement about an alkane. So let's read all four before coming into conclusion. So it undergoes electrophilic addition? Never. Okay, electrophilic additions are special for alkenes. Next, it undergoes nucleophilic substitution reaction with chlorine gas? No, we did not see that also. Alright, it undergoes homolytic cleavage when reacts with chlorine gas? Yes, we did see that in free radical substitution reaction. And just let's confirm the final one. It undergoes electrophilic substitution with an aqueous chlorine solution? No, it does not. So the answer is C. Right. Question 3. What is the IUPAC name for the following compound? So all you have to do here is to identify the longest chain. So let's count. 1, 2, 3, 4, 5, 6, maybe 7 and 8. Alright, so that would be the longest chain. The next thing you have to make sure, right, your substituents are on the smallest number. As I can see from here, numbering from left to right is giving bigger numbers on my substituents. So what I'm going to do is, I'm going to erase this and I'm going to start numbering from right to left. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my longest chain would be this here. So as I've mentioned in class, always try to box your longest chain so that you can circle your substituents. So we have got 3 substituents over here, and 2 of them are methyl at position 3. Okay, at position 3, we have got dimethyl substituent, and at position number 5 we have got a benzene ring. So when benzene ring becomes a substituent, okay, it carries the name phenyl. So let's match that. The answer would be A. Alright, the longest chain with 8 carbon would carry the parent name octane. Next, number 4. Which of the following reaction is a free radical substitution reaction? I think you should be very clear now from the lecture notes that there was only one reaction under free radical substitution that we saw, which was halogenation of alkenes. Next, which of the following has the lowest boiling point? So when we talk about lowest boiling point, you must remember that the van der Waals force must be the weakest. Okay, and the weakest van der Waals force comes from smallest contact surface area. Okay, so now all you have to do is you have to see which of the following has got the least contact surface area. So least contact surface area is usually our cyclic, not cyclics, more branched. Okay, more branched alkanes which are spherical, okay, which are spherical and compact. So we have to find which of the following is the most branched. Now as you can see here, C5H10 indicates it's a cycloalkane. because it matches with the general formula CnH2n. Alright, and these B, C and D are all straight chain alkanes with D having no branch. As you can see, none of the CH3s are in bracket, and here we have got 2 CH3 in bracket, indicating that it's a branch extending from this carbon over here. And finally, as you can see here, this is all CH3s are basically surrounding the carbon, compact, and it is spherical. Right, so that's the answer, B. Okay, if you're not convinced, you can still draw it. Okay, now another one more point to look out here is that you must make sure the number of carbons are the same when you're comparing this. So as you can see, this is C5, this is also C5, and what about this? This is C5, and also finally we have got C5 as well, meaning you apply this when you have noted that all the number of carbon is the same, because if the number of carbon is going to be lesser, obviously it will have a lower boiling point compared to a alkane which has more number of carbon. Okay, so that was actually supposed to be the first thing you must check. I forgot to mention that, but now that I'm saying that, you must first check the number of carbons. Okay, in this question all the number of carbon is the same, so all you check is whether it has got the largest contact surface area or the least contact surface area. So how do we know if it's going to have the least contact surface area? Find the one which has the most branch, because it will be more spherical and compact. Alright, let's move on to the next question. So ethane and bromine react in the presence of sunlight, but not in the dark. So why do we require the sunlight? I think we have noted in our lecture notes that sunlight is required for homolytic fission. So option A and D is wrong. And this homolytic fission would be our initiation step, if you can remember. So initiation step will be involving our halogens. So the answer would be C. Alright. Next, which of the following is a propagation step reaction between ethane and chlorine? So if you can remember, at the propagation step, chlorine is now a chlorine radical that we have formed from the initiation step. So A is the initiation step, it's not the propagation step, so that's wrong. Okay, and when you see two radicals coming in together, that's actually the termination step, whereby we combine the radicals to stop the reaction. Okay, so the answer is going to be either C or D. So now it should be the reaction of chlorine radical with ethane. So there you have it, chlorine radical with ethane over there. So the answer is C. Okay, right. Question number 8. Combustion of alkanes may produce. So here you have to recall that we have got three situations for the combustion of alkanes, whereby we have excess oxygen, okay, and we have got limited oxygen situation, and we also have very limited oxygen situation, whereby excess oxygen produces carbon dioxide and water as products. Limited oxygen situation produces carbon monoxide and water. Finally, if the oxygen supply is very, very limited, your products would be just carbon and water. So the combustion of alkanes here, they did not say which situation is this. So may produce water, definitely, carbon dioxide, and also carbon monoxide. So all three is our answer. Right. Question number 9. Okay, which of the following is or true about the CH bond in alkane? So our focus here is on the CH bond. Yes, it is a non-polar bond, and yes, it undergoes substitution reaction with chlorine. Okay, so the CH bond doesn't have a preference with reaction with bromine or chlorine. So the answer is just 1 and 2. Finally, which compound given below gives 3 monobromoalkanes. That means 3 monobrominated alkanes when reacted with bromine in dichloromethane in the presence of sunlight. So here you must remember, if we are getting 3 monobromoalkanes, that means there is 3 hydrogen environment. Okay, there is 3 hydrogen environment. So we have to make sure we find this 3 hydrogen environment. So let's start with hexane. So draw hexane. Hexane would be CH3, CH2, 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 and another CH3. Next, we are going to classify our carbon along with our hydrogen. So this is primary, this is secondary, this is secondary, this is also a secondary, and a primary. Okay, so here we are going to see whether are there any equivalent hydrogens. Okay, right. So now this primary CH3 and this primary CH3 are equivalent. Okay, because it is a primary carbon adjacent to a secondary carbon. All right. What about the next one? So we have got 4 secondary carbons over here. Are they all equivalent? Okay, the answer is no. If you realize, the secondary carbon that I've highlighted and the secondary carbon here is from the same environment. Okay, because this is a secondary carbon adjacent to primary and a secondary carbon. Same goes to here. And finally, okay, give me a moment. Let me highlight this so that you can see better. So this and this are of the same environment. And finally, okay, these 2 secondary carbons are coming from the same environment. Why so? Because this secondary hydrogen, okay, and carbon is adjacent to a secondary and secondary. Okay, same goes to the one on the right that I'm showing. Okay, this secondary carbon, it's adjacent to a secondary carbon and a secondary carbon. So in total, we have got 3 hydrogen environments here. So we can get 3 monobrominated alkanes from hexane. So that is a correct answer. Now let's look at the second one. Okay, let's look at 2,2-dimethylbutane. So let's draw that first. So that would be CH3. Okay, CH3, CH3, continued by CH2 and a CH3. Okay, so this is for 2,2-dimethylbutane. Let's classify the carbons. So primary, 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 and this here is going to be a quaternary. This here is secondary, and finally we have got primary. So I'm going to skip the arrows. Okay, so I'll just label this as secondary and primary. All right. So now let's check whether if all the primary carbon and hydrogens are from the same environment. So first, this primary hydrogen carbon and this CH3 and this CH3 are of the same environment. Okay, they are from the same environment because all these CH3s are adjacent to a quaternary carbon. Okay, however, despite this CH3 being a primary carbon and a primary hydrogen over here, it is not from the same environment because this carbon, all right, is adjacent to a secondary carbon. So that's a different environment altogether. So let's circle that differently. Okay, or maybe I shall use a different color. Okay, right. So we have got 1, 2, okay, and it's clear that we only have got 1 secondary carbon and hydrogen, and that would make a third hydrogen environment. Okay, so altogether we have got 3 different hydrogen environments which can give you 3 monobrominated alkanes when substituted, okay, with their bromine halogen. All right, in the presence of sunlight. Yeah, So that is possible. Now the third one, let's confirm whether the third one can give us 3 monobrominated alkanes. So let's draw 2,3-dimethylbutane. So 2,3-dimethylbutane would be CH3, C, CH3, okay, then another CH3 and a CH3. So this would be 2,3-dimethylbutane. Begin by classifying the carbons: primary, 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 and this here is a secondary and a secondary. Alright, so are the primary carbon and hydrogen of the same environment? Can you see the answer? Yes, they all are, because this CH3 is adjacent to the secondary carbon as well as this CH3, okay, and this CH3 and also this CH3. So all of them are adjacent to a secondary carbon, making them all the same environment. So in other words, all these 12 hydrogens are equivalent hydrogens because they are primary and they come from the same hydrogen environment. Next, we have our secondary hydrogens, which are also from the same hydrogen environment. As you can see over here, okay, let's use a different color. This is a secondary hydrogen which is adjacent to two primary and a secondary. Same goes to this. Alright, so this is a secondary carbon, the secondary hydrogen adjacent to a primary, primary and secondary. So here what do we have is that we only have two hydrogen environment. Okay, if you have two hydrogen environment, you can only have two monobrominated products. Whereas hexane has got three different hydrogen environment. Same goes to 2,2-dimethylbutane. It has got three different hydrogen environments. Okay, I hope you got that. And that's all for this video. Thank you.